All right, let's take a look at one of these Newton's law of cooling problems. And I do want to say that solving this particular problem takes quite a bit of work. But the amount of work you're doing, I don't think it's hard work. You're just plugging numbers into a formula, updating a formula, and then you find your final unknown. And for all these Newton law of cooling problems, this is the formula that you'll be using. T equals to Ts plus Ae to the negative Kt. And when you're doing these kind of problems, it's very important that you find your Ts, your surrounding temperature. Then you want to find your expression for K, and usually you need to find a final temperature or the amount of time it takes to reach that final temperature. Okay, so in this problem, there's a bottle of beer with a temperature of 80 degrees Fahrenheit. And then that beer is put into a refrigerator, and that refrigerator has a temperature of 40 degrees Fahrenheit. And then 10 minutes later, the temperature of the beer decreases to 65 degrees Fahrenheit. And then we want to find out how long will it take for the beer to drop to 45 degrees Fahrenheit according to Newton's law of cooling. Okay, so this kind of makes sense because the beer is starting with a temperature of 80 degrees Fahrenheit. And if you put a beer into a refrigerator where the refrigerator has a temperature of 40 degrees Fahrenheit, logically the temperature of the beer should decrease over time, and it does. And we want to find out how long it takes to get to 45 degrees Fahrenheit. Okay, so step number one is you need to find your surrounding temperature. And for this problem, the surrounding temperature is going to be 40 degrees Fahrenheit because the beer is being placed into the refrigerator. And once you're in the refrigerator, the temperature will be 40 degrees Fahrenheit the whole way. So your Ts is going to be 40 degrees, so 40 degrees Fahrenheit. So let's put the 40 there. And then the temperature is there plus Ae to the negative Kt. Okay, now if we read the problem, it states that the beer has a temperature of 80 degrees Fahrenheit. So there's a temperature of 80 degrees Fahrenheit at the beginning, which is time equals to 0. So what we're going to do is we're going to take those 2 points, or that point there, 0, 80, and we're going to plug it into our formula. So our temperature now becomes 80, and then the surrounding temperature was 40 as indicated at the start of the problem. Ae to the negative k, and our temperature is going to be 0, right? And if you take a look at this expression right here, e to the power of negative k times 0, which is the same thing as e to the power 0. E to the power 0 is going to be 1. Okay, so if I have my 40 here, my 80 there, this would be 40 plus a, right? So a times 1 is a. And if I solve for a, 80 minus 40 would be 40. All right, so after that, I'm going to go back and update my formula. So I'm going to erase all of this. And I'm going to erase that. So my surrounding temperature was 40. And basically the A is now going to be 40 as well. So if I erase that, I'll put a 40 there. And then I'll erase all of this. So this is what I mean by you need to continually update the formula after you start using pieces of information in the problem. All right, so the next piece of information we can use is that after 10 minutes, the beer has decreased its temperature to 65 degrees Fahrenheit. So after 10 minutes, our new temperature is now 65 degrees Fahrenheit. Okay, so what that means is our new temperature here will be 65, and then everything else remains the same. This will be 40 plus 40e to the negative k, and the time that we have now is going to be 10, right? 10 minutes. And what we're going to do now is we're going to solve for k. Okay, so if I subtract 40 from both sides, so 65 minus 40, so basically we're doing 65 minus 40 equals to 40e to the negative 10k. And 65 minus 40, that is going to be 25. So I'll erase this and I'll write down 25 over here. And our goal now is to solve for the k variable, right? And I can divide both sides by 40. And if we do that, we get 25 over 40 equals to e to the negative 10k. All right, and then from here you can ln both sides. So I can ln that side and I'll ln that side. And if I ln both sides, basically I have ln, I'll put in a bracket over here, 25 divided by 40. For sure you can reduce that fraction, but I'm not going to. And then what happens here is this negative 10k gets soccer kicked to the front, so negative 10k. and then we multiply that by ln e. And you should know that ln e, which is this part right here, ln e is just 1, right? So if you want, you can just erase the ln e, and now you have negative 10k, and you can divide both sides by negative 10, and then we get this weird expression where k will now equal to ln of bracket, well, 25 over 40. If you want to reduce the fraction now, you can. 25 divided by 40, if you reduce that, that's going to be 5 over 8. And this negative 10 on the denominator, for sure you can write that as negative 10, or you could write it as negative 1 over 10 times ln 5 over 8 equals to k. Okay, so what we're going to do is we're going to kind of box this, because this needs to be inputted into our formula, and then we can finally go and solve the problem and find out what we need to find. Okay, so what do I mean by update the formula? Okay, so let me kind of go back to all of this. Let me erase all this. And let me just kind of write this as just the capital T here. And what we're going to do is this k right here, we're going to replace that with, we just kind of discovered that k was negative 1 over 10 ln 5 over 8, right? So we're going to use that, and we're going to replace that for k. So if I do that, you'll notice that the minus sign here and that minus sign there, that'll cancel off, giving us a positive expression now. So let me just kind of erase this, and let me just kind of input this in as 1 over 10 ln 5 over 8. And that's being multiplied to the power of t, right? So that's that t right there. All right, so this is our new updated formula. And finally, what we need to do in this particular problem is, if I read the instructions again, we want to find out how long. So I'm just going to erase all of this now. The final part of this question is asking how long will it take for the beer to drop to 45 degrees Fahrenheit. Okay, so the temperature is now going to drop down to 45 degrees Fahrenheit, and I want to find out how long that's going to take. Okay, so I want to solve for t, right? I want to find out how long is it going to take to reach a temperature of 45 degrees Fahrenheit. Okay, so this capital T now becomes a 45 equals to 40 plus 40e to the power of 1 over 10 ln 5 over 8 times t. Okay, now we're solving this this pretty big equation here. This will take a little bit of time. Let's go ahead and subtract 40 from both sides. So if I subtract 40 from both sides, it's really 45 minus 40, right? So really we have 45 minus 40. And 45 minus 40 is going to just be 5. And then we have all of this, 40e. Actually, you know what, just kind of save a little bit of time here. For sure, if I bring that 40 across, that becomes 45 minus 40. So how about I just do this? We know that's going to be a 5 here, right? And then I need to divide both sides of the equation by 40 now. So divide that by 40 and divide that by 40. And then if I do that, we know that this and this will cancel. And 5 divided by 40, you know, I can leave that as 5 over 40 if I like. And then I can get that there. And let me just kind of rearrange this to be 5 over 40 over here. Okay, so I'm just going to erase some stuff there. Okay, so now I got to solve for this. And in order to solve for that, I need to ln both sides, right? So after that, I can ln, actually, hold on, let me create some space here. I can ln this side, and I can ln this side. All right, so now I'll write another step here. So if I ln both sides, I really have ln 5 over 40 on the left-hand side. And if I ln the right-hand side, then what happens is this part right here, I can soccer kick that to the front, right? I can soccer kick that to the front using ln property. So I have 1 over 10 times ln of 5 over 8 times t. And then it's being multiplied by ln of e, right? So ln of e. And we all know that ln of e, which is that right there, equals to 1. So now I can erase that, and I now can solve for my t variable. Okay, so basically if I solve for t, I need to divide the left-hand side by this long expression right here. And this is just really a massive ugly number here. So ln of 5 over 40 divided by 1 over 10 times ln of 5 over 8. All right, and if you go to your calculator and if you plug all that in, you should get an answer of 44.243 minutes. Okay. Now, when you're putting this into a calculator, my recommendation is I would put this into the calculator first, find that answer, and then I would divide by the numerator. Okay, so what does that really look like? All right, so I have it ready here. So I would put this expression, the denominator, into your calculator first, find out what that equals to. All right, so some weird negative number, and then type in the numerator, which is ln of 5 divided by 40, I believe. All right, hit enter, and then divide that by, actually, sorry. Okay, so there's the previous denominator, and then I would type in ln of 5 over 40, and then we just divide that by the answer that we had. Oops. Hold on, I'm botching this right now. So ln of 5 over 40 divided by second answer. There you go. And there you go. There you got 44.243 minutes there. Okay, so I'm sorry that I kind of botched that a few times. So I was just saying that on your calculator, calculate the denominator first, and then take your numerator and divide by your answer, and then that way you can get the final answer correctly. Okay, so there it is, 44.243 minutes. And that should do it. Before I finish up with this problem here, I want to erase all of this, and I just want to talk about what does this really mean. All right, so what does this answer really mean? Okay, so if I have a graph right here, I'll call this the temperature here. So I will call this the time over here on the x-axis. So when you have a time of 0, I guess the temperature is going to be at 80 degrees. And then what's going to happen is that the graph is slowly going to just decrease, and then it's going to level off over time. All right, so if we had to kind of plot the points here, like if this is 10 minutes right here, maybe this is going to be 65 degrees Fahrenheit, and the answer that we found was what, 44.243. If I just level that on the graph, I guess this temperature would now be 45 degrees. And the thing about Newton's law of cooling is if you go forever, basically what's really happening is that the temperature levels off to a height of the surrounding temperature, which is about 40 degrees Fahrenheit, right? So if you had to really go off on a horizontal asymptote, which is what that is, the temperature is really leveling off to 40 degrees Fahrenheit. So that's how these Newton's law of cooling problems are behaving. Okay, so that graph right there was just for interest. You didn't really need it to solve the problem, but it's just there for general interest there. Okay, let's take a look at another Newton's law of cooling problem. So in this question, there's a pizza cooked in an oven at 200 degrees Celsius, and it's put into a room with a temperature of 20 degrees Celsius, and how long will it take for the pizza to reach 60 degrees if it drops to 120 degrees after 15 minutes? Okay, so first things first, a lot is going on. So a pizza is cooked in an oven at 200 degrees Celsius, and then once you take it out of the oven, it's put into a regular room with a temperature of 20 degrees Celsius. All right, and I guess that pizza is going to remain in room temperature, so that means your surrounding temperature here is going to be 20. So let's go ahead and update our formula here. So T equals to 20 plus AE to the negative KT. All right, so after that, we know that at the beginning, the temperature of the pizza is 200 degrees Celsius. So at the beginning, the temperature is 200. All right, so using that, we can update our formula here. So this means the capital T here is going to be 200 equals to 20 plus AE to the negative K, and then multiply that by 0. And then we can solve for A there, and if I subtract 20 from both sides, this would give me 180 over here, and then I have AE to the power of 0, and basically e to the power 0 is going to be 1, so that means my coefficient of a is going to be 180. Okay, so I'm going to erase all this, erase that, and I'll put 180 right there. Okay, perfect. Alright, so basically if I keep on reading the problem, it says that the temperature drops to 120 degrees after 15 minutes. So after 15 minutes, the temperature of the pizza is now 120 degrees Celsius. And that makes sense, right? So if you take a pizza out of its oven and leave it in room temperature, over time, the temperature should decrease over time, right? And basically the question is really asking, how long will it take for the pizza to reach 60 degrees Celsius, right? So eventually it's going to drop to 60 degrees Celsius, and I want to find out how long is it going to take. Okay, let's go ahead and take this part of the problem, the 15 minutes and 120 degrees Celsius, and let's plug that into the formula now. So this capital T now becomes 120 equals to 20 plus 180 e to the negative k, and then that's going to be 15. Okay, and then let's go ahead and do a little bit of math here. I can subtract 20 from both sides. So 120 minus 20 is going to be 100. All right, and then I can divide both sides by 180, divide that by 180. Okay, so basically if I just move this around, I guess this and this can cancel. All right, so I'm going to erase that. I'm going to put an equal sign over here, and I have, I'm going to move this over as 100 over 180. Okay, so just kind of move that around, and then after that, I can ln both sides. So I'm going to ln this, and then I'm going to ln that. Okay, so my next line, if I ln 100 over 180, totally fine. I can take this part of the problem, negative k, so negative k times 15, and I can soccer kick that to the front. So that's going to be negative 15k times ln of e. All right, and then I know that ln e is that ln e there, and ln e is going to be 1, so I'm going to erase this now, and that just becomes negative 15k. And then from here I can isolate for k now, so k would equal to ln of 100 over 180 divided by negative 15. Okay, and from here on, I guess you can simplify the fraction here. 100 over 180 in reduced fractions, I believe that's going to be 5 over 9. And instead of having the negative 15 on the denominator, you can multiply that by 1 over 15 as the coefficient. So negative 1 over 15 times ln of 5 over 9, and that equals to your k value. Okay, what I'm going to do now is I'm going to go back to the original formula here, and I'm going to update things. So I'm going to erase all this. So for sure there's quite a bit of algebra to do in these kind of problems here. So I'm going to, basically now I have t equals to 20 plus 180 e, and I just found out that k was what? K was equal to all this, right? We're going to take that value and we're going to insert that into that right there, right? So you'll notice that there's a minus sign here, right? So a minus times a minus will give you a positive answer, right? So let me just kind of fill this in here. So this will be 1 over 15 ln of 5 over 9 times t. Okay, so now we're going to continue solving the problem, and basically the last piece of the problem is that how long will it take for the temperature to get to 60 degrees? Okay, so this capital T now becomes a 60. This becomes a 20 plus 180 e to the power of 1 over 15 times ln of 5 over 9 times t. All right, and then after this, I'm going to spend the rest of the time solving this algebraic problem here. So let me just erase all this so it's all neat and tidy. So I can subtract 20 from both sides, right? So 60 minus 20 is going to be 40. So I'm going to erase that, and that's going to become 40. And then I can divide both sides by 180. If I do that, then this and this cancels off. So then I can erase that. So this equals to, and I'll write down the 40 over 180 over here. All right, so a lot of algebra here, right? And then in order to bring this expression down, I need to ln both sides. So I ln this side and I ln that side. Okay, so now I'll write a new line here. So ln of bracket 40 over 180 equals 2. And just as mentioned in the previous step, I'm going to soccer kick that to the front. So 1 over 15 times ln of bracket 5 over 9 t. And then I can multiply that by ln of e. Alright, and I said this a few times already, but ln e and ln e, that becomes 1, right? So I can just erase this, and I have that now. And then I can divide both sides. I need to solve for t, right? So I can divide both sides of the equation by this expression right here. So I can divide that by 1 over 15 times ln of 5 over 9. And that's what my t value would equal to. And once again, when you have an expression like this, I didn't do a good job on the previous example, but I would put this into your calculator first. And let's see if I can do that correctly this time. So I will clear all of this. So let's put a bracket and 1 divided by 15. And then I can times that by a ln of 5 over 9. And then just hit enter. That gives me negative 0.039. And then the numerator was ln of ln of 5 over 9. Actually, hold on. What was, sorry. It's going back here. So the numerator was 40 over 180, right? So so that would be ln of 40 divided by 180. It takes a little bit of time to get this right. And then I'll divide that by the answer. And then that should give me 38.383 minutes. All right, so going back to my answer key now. So after all that, time would equal to 38.383 minutes. Okay. All right, so that's how you do that particular problem. And just before I finish off here, I don't mind constructing a simple graph of this problem here. So if I just erase all this, erase all that, let's just have a really quick graph of what's going on here. So once again, let's just draw this long graph here. The temperature is on the y-axis, time is on the x-axis. So when time is 0, I guess our temperature is at 200. And basically the graph is going to behave where it's just kind of decreasing like that and it levels off, right? So once you're at 15 minutes here, so 15 minutes if I go straight up, sorry, 15 minutes if I go straight up, roughly the temperature is going to be 120. And then what we found was at 38.383 minutes, basically the temperature is going to reach 60 degrees. And basically what we're also just saying here is time goes to infinity, this thing levels off, right? It levels off to a certain temperature. And I believe that temperature that we are leveling off to is going to be the surrounding temperature, which is going to be 20. So if I keep on going forever, basically the temperature actually levels off to 20 degrees Celsius there. So there's a horizontal asymptote as we keep on going. I guess I didn't really draw the temperatures to scale here. I do apologize for that. But if I had to redraw this again, I guess that horizontal asymptote is going to be at 20 here. And then we had the other temperatures at 120 and 60 there. So that's what's happening in that particular graph. Okay, let's do one more of these Newton law cooling questions, and that will include this homework video here. So this time I have a frozen pizza with a temperature of negative 5 degrees Celsius. All right, so this time we're starting with a negative temperature here. So at the beginning, the initial temperature is negative 5 degrees Celsius. And then this time the frozen pizza is being placed into an oven, right? So in this problem, everything is being put into an oven, so that means your surrounding temperature for this case is going to be at 250 degrees Celsius. So 250 there, capital T there, plus AE to the negative KT. And then how long will it take for the pizza to reach 200 degrees if it's 100 degrees Celsius after 7 minutes? So after 7 minutes, it's going to be 100 degrees Celsius, and we want to figure out how long will it take for this pizza to get to 200 degrees Celsius, right? So that's the parameters given to us in this particular problem. We will go ahead and use the 0 and the -5 first. All right, so if I kind of speed this up here, this will be -5 equals to 250 plus a e to the -k times 0. And if I times all of this by a 0, basically that just goes away. And then if I subtract 250 from both sides, I get -255 equaling to a. Okay, so what we're going to do now is I'm going to erase all this, and I'll update that to be -255. So -255 for the value of a. All right, I'll erase all that. And then now I'll go back to my table here, and I'll use this part of the problem now. After 7 minutes, I have a temperature of 100 degrees Celsius. So this temperature will now become 100 equals to 250 minus 255 e to the power of -k, and my time now is going to be 7. Okay, and now I can subtract 250 from both sides. So 100 minus 250 is going to be -150. So if I erase all that, that's going to be a -150. And then I can divide both sides by -255. Right, and then basically that and that will cancel off. So I can erase all this now. And I'll write -150 over -255, and a negative number over a negative number is going to be positive, right? So I'll erase that and erase that. Okay, and basically this part here, this -k times 7, if I rearrange that, that's just -7k. So this will be -7k. And if I want to bring this power to the front, I need to ln both sides, right? So I need to ln this side, and I need to ln that side, right? So my next line, I'll write ln of bracket 150 divided by 255 equals 2, and then I can soccer kick this to the front, so that'll be, I'll put a bracket there, -7k times ln e. Alright, and then once again, I'll use a different marker here. This ln e is that ln e, and we all know that ln e is just 1, so I can erase that. And then I can divide both sides by -7, so k would equal to ln of 150 divided by 255, and divide by -7. And just like in the previous problems, I can put that in the front as -1/7 times all that, right? And I'll erase that. Okay, so that's my value of k. And this 150 over 255, if you want to reduce the fractions, that would be a 10/17. So that's your value of k, and then we need to put this back into our original formula. Okay, so what I'm going to do here is I'm going to take this k value and I'll replace it over there. Okay, so let's do that. Let's erase all this. And once again, you should notice that if you have a negative here and a negative there, right? A negative and negative, that gives you a positive power there. All right, so I'm going to erase all that, and I'll write this in as 1/7 ln of bracket 10/17, and then we have the time variable right there. Okay, so let me erase all this, and now we're in pretty good shape here. And the last piece of the last thing we have to do for this particular problem is use this part of the question. The temperature is now 200 degrees Celsius, and how long will it take? So I want to solve for this t, right? I want to find out how long it does it take. And this capital T becomes a 200. So 200 equals to 250 minus 255 e to the power of 1/7 ln of 10/17 times t. Okay, so a little bit of algebra here to finish this off. So this will be minus 250 minus 250. So 200 minus 250 will be -50. So I'll erase this. That becomes -50 there. And then I'll erase that. And then I can divide both sides by -255. Divide that by -255. mathematically this and this cancel off. I'll erase all that. Put an equal sign here, and this will be negative 50 over negative 255. I'll erase all that. And then that becomes positive. And then if I want to take this numerator here, and if I want to bring that to the front, I need to ln both sides, right? So I can ln this side and ln that side. Okay, so finally, after for a long time here, I can write another line here. So 50 over 255 equals 2. And all of this can get soccer kicked to the front. So 1 over 7 times ln a bracket 10 over 17 times t. And then I can multiply that by ln e. So ln e. And I mentioned a few times here already that ln e is just going to be 1. So I can erase that. And finally, I'm in a pretty good situation here where I can divide both sides by this weird expression. And if I do that, let's go ahead and write the final steps here. So actually, I'll just write it as this 1 over 7 times ln of 10 over 17. And I won't go to the calculator for this one here, but if we go to your calculators for that, that's about 21.493 minutes. All right, so that's how long it will take for this particular pizza to reach a temperature of 200 degrees Celsius. I would say in a graph like this, the graph is going to look a little bit different here. So if you had to write your temperature and your time here, I believe at the start the temperature was at negative 5 degrees Celsius. So it's going to kind of like start there, and then it's going to go up and then level off, right? So at various times that we're given, so I believe you know, when we're at 7 minutes, the temperature was at 100. And I believe at now this 21.493, if I go straight up, roughly the temperature we have there is going to be about 200 degrees Celsius. And the idea is if I keep on going forever, so the limit as time goes to infinity, basically this horizontal asymptote levels off, and it should level off at a temperature of 250 degrees Celsius because this pizza was put into an oven, right? So the oven's set at 250 degrees Celsius, and we're going to leave it at that temperature, and that's why the graph kind of behaves like that. All right, so thanks for watching this homework video guide. It was quite long, but hopefully you'll see that the Newton's Law of Cooling problem isn't too hard. You just got to keep on going back to the original formula and updating it through algebra. All right, thanks.